Alright guys, welcome to this page of the notes. Now what we're going to do here is again get some practice now with you actually graphing these transformations. I've got a bunch of example functions here. We're going to go through them one by one, graphing them onto the coordinate plane. So here we go, let's just jump right into it. The first one I've got for you is f of x is equal to x squared plus 4. Right away I recognize the x squared means I have a quadratic function. So I know it's going to be that parabola shape, that U-shaped graph. Now I need to figure out this plus 4. Is that an A, an H, or a K? Well, if it was an A, it'd be in front of the function, so it's not an A. If it was an H, it'd be inside parentheses with the x, and you'd have that quantity squared. Since it's not inside the parentheses with the x, it can't be an H. That means it must be a K. Now, remember, K means a vertical shift. And when it comes to vertical shifts, it works exactly the way we would expect it to. K is equal to 4. This means that I have a vertical shift up of 4 units. So instead of my U going through the origin, I'm going to shift it up 4 units. 1, 2, 3, 4. And my U is going to go up through here like that. All right? I'm taking that parabola and shifting it up 4 units. Awesome. Let's try another one. All right. In my next one, I recognize that it is now absolute value, right? These should jump right off the page at you. I have absolute value of x minus 3. Well, once again, A, H, and K. Well, if I had an A value, it'd be in front of the absolute value sign, and there's nothing but a 1 there, so I don't have a dilation. If I had an H, it'd be inside the absolute value sign with the x, and there's nothing in there, so it can't be an H. That means that my minus 3 must again be a K value, but this time it's a minus 3. Well, I remember from that previous page which had the chart on it, whenever the K value is negative, it's actually a vertical shift down. So my V is going to be, instead of going a V through the origin, it's just going to be shifted down 3 units. 1, 2, 3. And my V will now take off in this direction and take off in this direction. And there I go, I have my V, which would originally go through the origin if it was the parent function, but I've now shifted it down 3 units. Awesome, let's try another one. Get rid of that. All right, here we go. Now I have x minus 1. Okay, well, it's not an x squared. The x isn't in absolute value, so this has got to be my linear function. Let's try this again. If I had an A, it'd be in front of the x, and there's nothing out there. There's just a 1, so I don't have a dilation. If I had an H, it'd be inside parentheses with the x, and I don't even have any parentheses, so it can't be an H. That means once again, I have another K. This time, K is a minus 1. Well, I know that the parent function divides the first and third quadrant in half. I'm just going to take that whole guy and shift it down 1 unit, and so it looks like my guy is now going to run through here and back down through here, right? I've just taken that whole graph, which would have originally gone through the origin, and shifted it down 1 unit. It's still that linear function with a positive slope, just now shifted down 1 unit. Again, that is K. Fantastic. Let's try another one. Oh, sorry, that is a highlighter. No bueno. All right. Let's see, what have I got next? My next one, here we go. I have a negative 3x plus 2. Awesome. Now I've got multiple things going on here. What's A, H, and K? Well, if I have an A, there'll be something multiplied in front of the x. Fantastic. That's exactly what I've got. So I have an A that is a negative 3. This is going to do 2 things to my graph. First, the negative sign is going to mirror the graph, the parent function, across the x-axis. Flip it across the x-axis. So instead of being a line with a positive slope, it's now going to be a linear function with a negative slope, right? We're just flipping it across the x-axis. So that's the negative. What does the 3 do? Well, we remember that anytime A is a number greater than 1, we're taking our graph and we're stretching it vertically, right? So now I'm going to have a line with a really steep slope. In fact, a slope of 3. You should recognize this is y equals mx plus b. Yeah, I know, it just blew your mind. That's what we've got going on here, y equals mx plus b. Here's your slope, here's your y-intercept. But again, we're graphing transformations. This is going to be my k. K is equal to 2, so that means the whole thing is getting shifted up 2 units. So here we go. I got to go through 2. Let's see, it's going to be 1, 2, 3 over 1. So here we go. Should look something like this, a nice steep line. Because I have stretched it vertically, it is now negative because I flipped it across the x-axis and I've shifted the whole thing up 2 units thanks to my vertical shift. Fantastic. Let's try another one. All right, the next one I got here for you guys on the chart is going to be, oh, awesome. We've got a quadratic. Fantastic. Here we go. Let's see what's going on with this guy. What is happening with this guy? Okay, if I have an a, I'll have a number multiplied out front, and that's exactly what I've got. My a is equal to a negative 1/2. All right, no big deal. I know what's going on here. The negative sign is going to take my parabola, which would be opening up, flip it across the x-axis, so now it'll be opening down. The 1/2 is going to be a vertical compression, so my u is going to be much, much wider. And I also have, ooh, look at that. I have a negative 5 inside the parentheses, right? So I have the quantity x minus 5 squared. That's an h. H is equal to a negative 5. Now remember, h is the crazy one, right? Whatever the sign is of h, you actually shift in the opposite direction. So this is going to be a shift positive 5. All right, so here we go. Let's go ahead and make that shift. 1, 2, 3, 4, 5. So this is where my parabola is going to start. So I'll have a u opening down from this point. And I need to go ahead and make it a nice wide u. So make sure you make your u look nice and wide as you draw it in here, opening down. That looks like a fantastic u to me, right? It's nice and wide. That's what the 1/2 does. It opens down. That's what the negative does. And the minus 5 means I've shifted it 5 units in the positive direction. Let's try another one. Whoops. Uh-oh. There we go. My eraser wasn't working for a second, but we got it. Okay, here we go. We are plugging right along. Awesome. My next one is the absolute value graph, right? I recognize the absolute value sign, so let's go ahead and figure out what's going on here. I got a negative out front. Well, that means that a is equal to a negative 1. Okay, no big deal. I know that the 1, right, the 1 does nothing as far as a vertical stretch or a vertical compression, does nothing. But the minus sign means that my v is now no longer going to open up. My v is going to open down. Fantastic. And then I have a 6 inside the absolute value sign. That's got to be an h. And it's a positive 6. So now I know I need to go in the opposite direction. So I'm actually going to shift this v 6 units in the negative direction. So 1, 2, 3, 4, 5, 6. There it is. My v would originally open up, but since the negative sign, it's now going to open down. I don't have any sort of dilation, no vertical or horizontal, no vertical stretch or compression. So it just should look like a standard V. Don't make it extra wide. Don't make it extra skinny, right? Just draw yourself a nice little V like that, and you're all set. Here we go. Let's try another one. Let's see here. What have I got? Oh, yeah, awesome. Those are all going to fit. Okay, next one. I have for you, ooh, awesome. I got another quadratic, right? Because this quantity is squared, I should immediately recognize it as a quadratic. Let's figure out A, H, and K. There is nothing but a 1 out front, so I know that A is equal to 1, and that doesn't do anything. That is, 1 doesn't stretch or compress my graph. It's positive, so I know my parabola is going to open up. Plus 4, I got a plus 4 inside the parentheses, so that means that H is equal to 4, but I remember that H goes in the opposite direction. Since it's a positive 4, I'm actually going to move in the negative direction 4 units. And I also have back here a K. that's going to be a negative 6. And k, where it's exactly the way that we want it to when it's a negative number, you go down that many units. So here we go. I'm going to go over 4. I'm going to go back 4 because it's a positive 4. I need to go in the negative direction. 1, 2, 3, 4. I'm going to go down 6. 1, 2, 3, 4, 5, 6 right there. So this is where my parabola is going to start. Negative 4, negative 6. There is no dilation on the parabola, so just draw yourself a nice standard looking parabola. Should look something like this. Just a nice, easy parabola. All right, don't make it super skinny, don't make it super wide, just standard parabola. The parent function would have been here at the 0, 0 at the origin, but I've done all sorts of transformations to it that have moved it 4 units to the to your guys' left and 6 units down. Great. One last one, so let me go ahead and erase this. We got one more to try. Awesome, here we go. Okay, in this last one, okay, I recognize it as absolute value, and I got all kinds of stuff going on here. The first thing I notice is I have a minus sign out front. So that tells me that A is equal to a negative 1. Now, I know that the 1 does nothing as far as a dilation, right? There's no vertical or there's no vertical stretch or compression. But the minus sign means that my V is going to open down. Awesome. I have a negative 5 inside the absolute value sign. That's got to be my H. And because it's negative, I know I need to shift horizontally in the opposite direction. So I'm actually going to go positive 5. And then I got a plus 2 tacked on the end here, which that's going to be my K value. And we know that the vertical shift works exactly the way that we want it to. Because it's a negative 2, I'm going to go down 2. All right, here we go. Let's make this happen. Negative 5 means I go 5 to the right. 1, 2, 3, 4, 5. Negative 2 means I go down 2. So I'm going to start right there. That's where my V is going to start. My V needs to open down. I have no vertical stretch or compression, so just a standard looking V should look something like that. That takes care of all of my transformations. Guys, that's fantastic practice of taking a look at a function, figuring out what's your A, what's your H, what's your K. Go ahead and write them down. Then once you know what A, H, and K are, then just remembering from that chart what each of those does to your graph. Again, there's nothing I can do here. It just takes lots of practice. It requires you to memorize what A, H, and K do to a graph, and you just got to keep doing problems. So head on over to the next page of the notes, and we'll keep going. I'll meet you there.